Okay, when we were looking at the first two skills in this unit, it was all about finding a missing side in a right-angled triangle. When we knew two of the sides, we could then just find the third side, which was fairly straightforward. Here we're looking at what the relationship is between the sides and the angle, and that's where we start using trigonometry. So the first thing we need to be able to do is to label our right-angled triangle. So here I've got my right angle. So the first side that I label is always going to be the longest side, which is at the other side of the triangle from the right angle. So that's my longest side over here, and we're going to just label that with H, and that's my hypotenuse. We then need to find a way of labeling the two shorter sides so we don't get confused, and we label those in relation to whichever angle we're given. So what I'm going to do is I'm going to look at this angle, and I've got two sides. I've got the opposite side and the adjacent side. So the opposite side is going to be whichever side is the other side of the triangle from this angle. So here, this must be the opposite to that angle. So there's my opposite, and here, adjacent, which means next to, the shorter side which is next to that angle, is the adjacent. And I've got three buttons on my calculator which connect these three sides, and they're the sine, the cosine, and the tangent button. And the way we remember all of this, because there's a lot really to take in, is using this word SOHCAHTOA. And SOHCAHTOA is actually three formula triangles all in one. So it goes SO, CA, TOA. I'm just going to draw a triangle around each one so we remember that these are formula triangles. And as long as you remember the word SOHCAHTOA, you can remember all of this information. And those are really short for sine of theta is the opposite over the hypotenuse, cos of theta is the adjacent over the hypotenuse, and tan of the angle is the opposite over the adjacent. So the first thing you're going to need to do is work out which of those three triangles you're looking at. Well, let's have a go at two examples. So here I'm going to label the three sides of my triangle. So the first one I'm going to label is my hypotenuse, which is the other side from the right angle. So here I'm going to put an H there. Standing at this angle, I know the opposite side is this one. It doesn't have any information on it. The adjacent next to is my x. So the one that I'm not interested in is this opposite over here. Let's get rid of that. So what I want to know is which part of SOHCAHTOA connects up A and H. Well, the first bit connects up O and H, the second bit connects up A and H, the third bit connects up O and A. Well, here I've got A and H, so I'm going to have CA. I'm going to just rewrite that bit of the formula triangle, just so that we're familiar with which bit I'm talking about. So there's my CA. Let's have a look at what I'm trying to find. Well, I'm trying to find the adjacent here. That's where the x is. So covering that up tells me that I'm going to need to multiply my c and my h. Well, my c is cos of the angle. So I can say that x is equal to cos of the angle times by the hypotenuse. Cos of 5, cos of 20, cos of the angle, times by the hypotenuse. So let's have a go at that on my calculator. I'm going to type in cos of 20, make sure I close my bracket, times by 5. And it gives me an answer to one decimal place of 4.7 meters. Okay, let's have a look at the second one. So again, I'm going to start by labeling my sides. There's my hypotenuse, there's my opposite, there's my adjacent. I'm not interested in the hypotenuse, it's got no information on it. So I'm looking at which part of this connects up O and A, Well, it's this last part, O and A, is my tan function. So here, I'm going to rewrite my formula triangle, TOA. Now, here, I'm trying to find my A. That's where my x is. This tells me it's a division. It's O divided by tan of the angle. So I can say that x is equal to O, which is 4, the opposite, divided by tan of my angle. 4 divided by tan 30. Let's have a go at doing that on here. 4 divided by tan 30, making sure I close my brackets, gives me an answer of 6.9 meters. Okay. Pause the video now while you write down the worked examples, and then as soon as you're ready, we'll go on and try some questions. Okay, so here are 9 questions for you to try. For the first 6, you are simply finding the missing side using the examples that we did. For question 7, you are going to need to divide up the shape somehow to give yourself a right-angled triangle that you can use to solve the problem. Okay, good luck. Pause the video now while you have a go, and then when you're ready, press unpause to see the solutions. Okay, so let's have a look at the solutions. So for question 1, you're finding the opposite, so it's sine of the angle times by the hypotenuse, so sine of 12 times 22, 4.6 meters. For the second one, you're trying to find the adjacent, so in that case you're doing cos of 31 times by the hypotenuse, which is 12. For the third one, you're trying to find the opposite, so it's tan times the adjacent. For the fourth, you're trying to find the adjacent, so it's cos times the hypotenuse. Question 5, be careful, it starts getting a little bit mixed up here because you're trying to find here the hypotenuse, so it's the opposite divided by sine of the angle, 5 divided by sine 18, and for the sixth one, again it's a division, you're trying to find the adjacent, so it's the opposite, which is 8 divided by tan of 45, which gave you an answer of 8. So mark off those 6 there please for me, hopefully most of us got 6 out of 6. For question 7, 8, 9, it's a bit more complicated. You need to do 2 steps. So for the first one, you're going to split this up into a right-angled triangle, and you're going to find this bottom length here. That's going to be a cos problem, so that's cos 60 times by 10, give you an answer of 5 meters. Remember that only gives you half of the base, because you're going to need to double it to find out the full length, which gave you 10 meters. This is in fact an equilateral triangle, 10, 10, and 10. Here, again, you're going to halve that to give you 2. You're going to use cos 60, so it's going to be x equals 2 divided by cos 60. 2 divided by cos 60 gave you 4, so that's going to be 4 centimeters. And again, you've got an equilateral triangle. Question 9. Here you're going to have 2 meters at the base here. You've got 2 meters on either side, so there's 2 meters on the base. You've got 70 here, so it's a cos problem. 2 divided by cos 70 gave you x equals 5.8 meters. Those last 3 really are pushing the very, very top of the foundation tier. Give yourself a mark out of 9. If you need any more assistance on those finding sides in trigonometry, please take a look at Hegarty questions 512 to 513. Okay, very well done.